Welcome, everyone. My name is Joel Pelly. This is Drew McDaniel. We're from the Azure Compute PM team under Corey Sanders. And we're going to talk to you today about mapping your workload to the right Azure VM type. So if you're not here for that, you're in the wrong place. So we're going to kind of cover this by going through a few different areas. And what we're hoping to do is give you a little bit of background and a little bit of history and a little bit of scope as well to help you kind of understand where we're at today by going back a little bit in history and talking about how we got started, how our VM types got started, and how they've grown since the beginning. And as we go through that, once we have that foundation laid, we'll actually talk about how they map to different workloads, right, for you, so you can look at those. And then we're going to actually take a deep dive into a couple of specific families we selected, primarily because these are the families, in some extent, that are a little bit newer, and also because we get a lot of questions about these. And so we figured they're actually really great ones to cover because in some cases, hopefully they'll help make some clarifications for everybody, which will help then, again, map them to your workloads better because you'll know how to use them. And finally, we'll talk a little bit about VMs that are coming up really soon in the near future. So we have a couple to introduce and talk about. They've been talked about a little bit already, but we'll go over them again here today from some of the other keynotes, and we'll wrap up from there. So getting started, Azure has expanded. I don't know when the last time is somebody's looked up our regions or maps, but we're growing. And it's fantastic. And one of the cool things about Azure is, right, we have 54 regions worldwide. So we have more regions than any other provider in the world, right? And a big part of what we're trying to do is make sure we're as close to our customers as possible. That's our thing. That's what we do. That's what we know our customers want. And that's why we have the number of regions we do. We want to be closer. And so in order to do that, we've laid now over 100,000 miles of fiber and cable, crossing the world many, many times. So it's just a phenomenal amount of connectedness to put this all together. And then on top of that, we also have over 100 now, 130, and growing edge sites around the world as well. Again, bringing those services even closer to the customer for things like Bing, Office 365, and other applications to make sure we're right where you are and where you want to be. So when we talk about our data centers and talk about growth, I'd love to show a couple of pictures of the data centers that we have. So this is West Europe. And a couple of things to point out is, number one, these are some of the new facilities that have been put in the last couple of years. And also a couple of things you can see in the picture, and then you'll see in a couple of the pictures, is the fact that there's wind power, right, which is important. And you can kind of see in the background, there's also area for growth and expansion that's already kind of being created. And so you'll see that again, as we look at West Central US. So this is another growing facility for us in a growing area. You can see already being prepared to expand. Notice the wind in the background. North Europe, again, and each data center, each facility is a little bit unique depending on the offerings and services and everything we put there and bring to the customer, right? So you're going to see some of that uniqueness as you go through pictures. And then West US 2 as well. So these are some of the new facilities that were very recently opened. And what you can't see in this particular picture, but if you could look to the east and west, you'd actually see a ton of, again, windmills generating power in the area. And also there's a couple of hydroelectric dams just upriver as well, up the Columbia. And it's kind of interesting now because as our footprint has expanded, we actually now consume more power than the entire state of Vermont, as a fun fact. And what's also cool about that, and the reason I related that to the wind and the water power, is because we already purchased over 1 gigawatt of clean energy from wind and solar around the globe, and we're constantly working to expand that as well. So to talk about history, I'm going to hand off to Drew.
Excellent. Thank you, Joel. So I've been in the Azure team for 7 years, and so Joel said, hey, you're the dinosaur. Why don't you walk us through the history? Since I was around for some of that, or a lot of it at least. And so we're going to talk about how we evolved. And the idea here is to give you a little bit of an overview of the evolution. Some of the sizes will make more sense as we look at the full spectrum that we have in offer. So when Azure launched in 2008, it was as the preview in 2008, and then GA in 2010, we launched with a set of sizes, small, medium, large, and extra large. And then shortly after that, we added the extra small. And so back then, it was a fairly different thinking that would be the entire set for the cloud. Everything in the cloud would be scale out in these kind of small to medium sized servers. And they just picked the names that would cover the entire set. But what we've seen is not really played out that way. And as we go through this history, it'll make some sense. So in June 2012 is when I say Azure really launched, or relaunched. It was when IaaS was available. We switched to a naming scheme of this A series with a set of numbers. And honestly, at the point in time, the thought, hey, let's just make it A through 0 through whatever it ends up being, and you'll use a secret decoder ring to figure out what the individual sizes are. And so we mapped over the extra small to A0, the extra large is A4, and then we added A5, 6, and 7, which was higher memory machines. And because with IaaS, we had a lot of customers looking to use things like SQL, and SQL needed more memory than the traditional websites that were running on Azure at that time. We then, a few years later, added these things called basic VMs. Basic VMs are not heavily used today, but at the time, Azure, the A series was a little more powerful than the competition, and so we introduced the basic at a little bit lower price point that had the same processing power as the A0, A1, A2, to have that kind of similarity across the different offerings in the cloud. Then in May of 2014, we introduced the first sizes to use remote direct memory access, or RDMA. Leverages the InfiniBand technology. And this has been a part of the focus within Azure to really cover the high-performance computing space that really wasn't covered well across the industry. This allowed for the interconnected HPC applications where you need really low latency. It's latency on the handfuls of microseconds in latency with InfiniBand. And that was with the A8 and A9 that was made available. Then we introduced the first set of sizes that we use as D series, and in fact, the D series exists today as kind of the workhorse VM. And this is kind of our general purpose focus of VM. This is the first set of VMs that used SSDs as the local storage on the machines. Now you see most of our sizes, there's a few exceptions after this, but most sizes continue to use SSD for local storage. We then introduced in the end of 2014 the first set of VM sizes that use what we call premium storage. And so you see this introduction of the S variation of VMs. When you see an S in any of our sizes, that means that the size is optimized for premium storage. And what that means is we actually take some of the local disk and leverage that for caching of premium storage. And so when you deploy a premium storage disk, you can configure it to do read caching or read-write caching, and it's leveraging the local disk to really accelerate the performance of premium storage. Of course, premium storage itself is also using SSD in the back end. Then in January 2015, we launched the G series. At the time, that was kind of being called the Godzilla, and it was actually the largest VM in the public cloud. It had a half a terabyte of memory and 32 vCPUs, which it's surprising that just 3 years ago that was the largest thing. Now that's actually kind of a modest-sized VM. It seems kind of quaint in retrospective. But at the point in time, that was the largest VM you could get anywhere in the public cloud. The A10 and A11 actually was the same as the A8 and A9, just removing the InfiniBand because we found customers wanted higher performance, high frequency sizes without paying for the extra of InfiniBand, and so we introduced the A10 and A11 sizes. And then we introduced premium storage version of the G series a little bit later. Now then, September 2015, see, nights kind of in September, so we see a lot of these things popping up in September. We introduced the next version of D series. And so this moved us from a Sandy Bridge-based system to a Haswell-based system. And again, this is the first time that we actually had a simultaneous launch of the S and non-S variations of the size at the same time. We still see a fair number of customers using the D and DS V2 sizes. The other thing I'll point out on those is, on the D and V1 and V2 is the fact that we used 1 through 5 to represent what we call a standard memory configuration, which is about 4 gigs per core, and we used the 11 through 15 to represent the higher memory, or about 8 gigs per core. And you'll see how that changes a little bit later, but that was kind of the naming scheme was being used at that point in time. Then we introduced the F size. The F size is focused on our compute-intensive, a little bit lower memory configuration. This is the first time that we actually introduced our kind of new numbering system. Before, the numbers actually just represented an index. And so, for example, a G5 was 32 cores. That was a little hard, at least for us to remember, even harder for customers to remember. So we thought it'd be easier to move this to the number representing the number of vCPUs on the machine. And so, for example, an F8 is 8 vCPUs, and F16, 16 vCPUs. At least it makes it easier for us older people to remember, I guess. Moving forward, we introduced in 2016 this N series of sizes. Now, N within Azure represents our GPU-based sizes. These are today all based on NVIDIA, so that's kind of where we got a little bit of that inspiration for the N size. We also introduced this notion of the second letter, which indicates what type of GPU it's for. So, for example, the C is for GPU-based computing. The V is for visualization. The H series was then the successor to that A8, 9, and 10, and 11 for HPC. This also has the InfiniBand. It also, you'll find, that is currently the highest frequency size that we have available. We also introduced this notion of M in the naming that would imply higher memory. And so instead of having the tens digit represent memory, we added these letters to indicate higher memory, or the R for RDMA, to kind of make it simpler for customers to understand. AV2 was launched in August of 2016 as well, and AV2 was really about taking that basic A size that we had, of the original A size, and moving that forward to SSD. At this point in time, we were buying very limited amount of hardware that would have traditional hard drives in there. So we really wanted to move that to SSD because that's honestly what was being purchased and a cheaper overall price point at that point in time. The L series introduced the size that's targeted at local storage, and so it's got a large amount of local SSD. The L series is the first one that was available for premium storage, but actually doesn't use the caching. Again, on those, we tend to see customers using premium storage for the operating system drive, but they're not using as many data drives using premium storage on the L series because the focus is storing a lot of data locally on those SSDs and replicating them to other machines in the virtual machine layer. In July of 2017, we launched the DV3 family and the DSV3 family. We also introduced the E series, which was what used to be the 11 through 15 version, again, making it a little bit easier to understand. This was actually using the same hardware that we use for the V2, but we moved to hyper-threading. So with hyper-threading, we enable multiple threads to be off of each physical core. It allows for an overall higher amount of performance coming off of the hardware, and then results in a little bit lower cost for the customers for those machines on a per vCPU basis. We also introduced at Ignite last year the B series, which is a burstable set of machines, and I'll talk a little bit more about the B series on how that can be very, very useful for your workloads, but again, you need to know a little bit about it to make sure you use that effectively. We also introduced last year this set of what we call suppressed cores, or database optimized sizes, and Joel's going to talk a little bit more about that, and so we'll save the details on that one until a little bit later. The F series, FV2, is the next generation of F. This is our first size that was available on the Intel Skylake processor, so using like the AVX512 instruction sets, focusing on kind of those compute-intensive workloads. It's also now, it was at that point the largest size that was available, going up to 72 vCPUs. Then the successor to Godzilla, the Mecha Godzilla, our M series came out. This actually put Godzilla to shame in the fact that it moved up from a ½ terabyte of memory to up to 4 terabytes of memory, 128 vCPUs. This, again, is a system that's really used for those in-memory types of databases. S4HANA, SQL Hekaton really leverage that M series quite well. And then earlier this year, we launched what we call the isolated sizes, and so the E64i and the E64is. These are sizes that are guaranteed to be dedicated to a specific piece of hardware, isolated by itself on a node so that you know that there's no other customers running with that on that same physical hardware as when you're running. And then finally, we added to kind of move forward and equal out with our D15V2 an E20, so a 20 vCPU size there. So now how do you make use of all of those different sizes? How do you actually compare them? And that's where the Azure Compute Unit comes in, or what we call the ACU. This is designed to help you understand the difference in overall CPU performance across the machines. We baseline this using the A series. That was our first VM, and the A1 equates to 100 ACUs, and then we go up and down from that. This specifically is a CPU metric, so memory does not come into play here. Memory is a little bit easier to tell the difference and expect how it's going to impact your workload. It also does not include anything around the GPU. The GPU performance is going to be very dependent on the specific workload, and so we don't really have a nice simple metric right now, at least for the GPU ratings, but the CPU-based ratings, the ACU works really well. And so, for example, if we look at the AV2 compared to B, it's interesting. AV2 has a fairly narrow range from 100 ACUs to 800 ACUs. 800 would be the 8-core version of the A series. But the B has a much wider range, and we'll talk in the next slide about how that is and how B bursts at different times to get both faster and slower than the A series. Scrolling up to the next kind of iteration, then we have our DV2 series of machines and our H series of machines. And as you can see, they're much faster at a much higher end than you can get on the A series, going all the way up to the H series, which is at 16 cores, and at that point in time was the fastest processor that we had at 2.9 gigahertz, was the fastest in that kind of generation. And then moving out to now our current generations, you see that we add the V3 sizes that actually go a much higher top end at 64 vCPUs, the FV2 going all the way up to 72 vCPUs, and then the M series going all the way up to 128 vCPUs. So the M series, the full size, can actually be more powerful than the F series, even though the F series is slightly faster. And so a nice way to look at that is the difference on a per vCPU basis is what we call the ACUs per vCPU. So if we look at, hey, how powerful is each individual vCPU, then you can see that, for example, the B series is not very powerful on an individualized basis or individual CPU, but the H series and the FV2 series are very powerful from an individual vCPU basis. And so that's why if you're doing a really compute-intensive workload, something that's really pushing the CPU, the H or the F series are the VMs that you'd want to run. Then the other pivot that's worth looking at is then the price. So if you turn it around a little bit different, and this is the dollars per 1,000 ACUs, and this is where you see some of the things like memory come into place. Of course, the M series that has a tremendous amount of memory. It's a very high price per ACU for the ACUs you're going to get out of that. The B series as well is a high price for the ACUs that you can get on a steady state. But if you're using B series where it's targeted at, it actually can be very economical, and I'll talk about that in just a moment. So Joel, I'll hand it back to you for walking us through some of the different workloads and how those use the different sizes.
Awesome. So when we talk about our virtual machines, when we talk about how they're spread out, we have a series of workloads that they can run. And as we build them and design them and expand them, there are workloads that we have in mind and envision and talk with all of our customers about to try to fit where we want to be with our VMs and where you want to be with your workloads together. So when you're looking at things like smaller websites, dev test workloads, small databases, things like smaller databases in SQL Server, applications in retail sites like WordPress and stuff like that, then you're really thinking about that AV2 or that B series that Drew was just going over before. And if you're thinking about larger websites, larger web applications, SharePoint, dev environments again, but bigger dev test, heavier applications, now you're looking at our DB2 and our DB3 series, more in that general purpose area. So then, bumping that up, going back to what we were talking about before on high performance websites, high performance computing, if you're looking at batch processing, some gaming, some modeling as well, and here, now you're looking at our compute intensive F series. And if you're looking at things where you're talking about large databases and memory databases, something like SQL, Oracle, Hekaton, SAP HANA, stuff like that, then really you're looking at that M series or an EV3, which again, the EV3 series is one of the newer series, and it's that split from the period where we did everything in a D. That E is now that top end D as we've gone forward into our V3. So it used to be D11 through 15 in a V2. Now the E series replaces that going forward. So it's effectively think of it as a higher memory version, right, of the D series. So the DV3 and the EV3 are very related, the EV3 being a higher memory version of that. And as you move forward and looking at graphics now, you're talking about a lot of compute-intensive, graphics-intensive, visualization, machine learning, AutoCAD, AI, other elements like that. Now you're into that N series that we're talking about. And we have a different series of VMs in there, depending on primarily the GPU that is in the hardware that you're able to access. And it's kind of how they're set up right now. And we'll talk a little bit more about what that's going to look like going forward as well. And then if you're looking for more of your really, really high-end compute, really high-end performance, that InfiniBand network, you're doing things like batch processing, analytics, molecular modeling, oil and gas, other things like that, workloads from customers like Milliman, Towers Watson. Now you're thinking about our high-performance compute in our H series. And then finally, if you're looking at storage optimization, so you're looking at that local storage on the node, direct access from the VMs to that storage, crunching that data back and forth, now you're talking about our L series, right? And you're talking about that locally. And then the finally, is we also offer other options right now in bare metal as well. And so bare metal is kind of that bleeding edge for us right now. It's that really, really, really hot, high-end place where we're actually able to offer things even up to, we were talking before about an M series, we were talking about 4 terabytes. Now you're talking about maybe even up to 20 terabytes in bare metal as a memory option. And what this also helps us do is we're innovating with our partners in SAP or Cray or others, is it helps us then look at the workloads that customers are going to be using and understand kind of from that where we're going to be going in the future, which helps us come back to things like our M series, which we'll be talking about and you'll be hearing more about in the future with new sizes coming from our M series that are going to start to push that 4 terabyte boundary further and further up as we get closer to bare metal, which is kind of leading that bleeding edge and leading us to where we want to go in that space. So it helps inform that space for us as we develop the new sizes and grow them. And so speaking about burstable, so this is a good one for Drew to cover in terms of what is it, how is it, and how do you use it? Because a lot of customers ask us questions about this. So we wanted to really hit on it.
Thank you, Joel. So as mentioned, as Joel mentioned, the B is our burstable size. Now what that means is the CPU on the B can vary. And what it ends up happening is each size has a number of vCPUs that's available to it, and then a base performance. And so for example, if you look at the B1, the base performance is 10% or 0.1. And that is the performance that size will have if you push it all the time, hitting the CPU as hard as possible. It would run about 10% of the reference. And the reference here is the DV2 size. And so it would run about 10% of a DV2 all the way up to the standard B8 that is 1.35. That's 130% of a single core of a DV2. And so that's kind of how that is. But the idea with burstable is it's for workloads that aren't being used constantly. So they're not targeted at your HPC workloads where you're doing a ton of number crunching. They're targeted at smaller websites or maybe hit infrequently, potentially a developer workstation. Because what happens when the machine is idle and running below that baseline, it starts to accumulate these credits. And so that's what you see in that second to last column. It's the amount of credits the size accumulates each hour. And so as you see that goes up. And then if there's credits that are available, the machine will burst all the way up to 100% of the per vCPU of the reference in this case, and it burns off those credits when it's bursting. And so then you can accumulate these credits. Again, that increases as the size goes, so that you can run for a period of minutes running at the highest possible frequency. But then when it goes idle, it will start accumulating that. Now, I think it's useful to actually walk through this with a little bit of a demo. It kind of shows it a little easier. So what I have here is a machine that's configured. I've got two VMs deployed, and I've got an A-series VM and a B-series VM. And the way that this is structured, and I'll just actually show you. So I've got a simulation here running that's going to wait a period of time and then wake up and then peg the CPU, processing the multiple rows of data. And as you can see here on the A-series, that processing takes about 30 minutes. And if you see back in the portal, it is very consistent. It's 30 minutes each time, very, very consistent in how it's operating. But if you look at the B-series, and if we zoom in on this one, you see that the B-series is operating in the charts here look very, very different. And so for the B-series, there we go. You get some cases where this looks similar to the A-series, and if we actually look at this, we'll actually see from 10 o'clock to 10:16. So it's about 15, 16 minutes to process it. This is where where it has the credits, it's able to go all the way up to 100%. And as you can see here, this lower blue line is the credits. And so the credits are accumulating up until the point in time the processing starts. And as the processing starts, these credits reduce down. Now, if you look over in the next section, though, the credits were not quite enough to complete the entire workload. And so you see it go from running at 100% to the point where the credits drop below 1. And it starts running at the 20%. So you see that smaller segment there. You can see that a little bit of credits are building up, and it pops up again and then comes back. And so on the machine itself, if you were to look at the B-series machine, you'll see those curves. And so in some cases here, we're processing it in, right, here's the curve where we're processing it in 13 minutes, so it's much, much shorter than the A-series, but it can be much longer here. In this case, it's 37 minutes, and we've even seen some that can be upwards to like 45 minutes on that processing. And so the key here is with the B-series, it's a very, very good thing if it is something that's an intermittent amount of workload, but you definitely want to make sure to monitor and keep an eye. And so, for example, if your credits are consistently high, you may actually want to throttle that down and drop it down to a smaller B size. If your credits are hitting 0 a lot, then you may want to go up slightly. And by the metrics that are available in the portal, you can really dial that in. If you dial that in, then you do end up saving a large amount because the B-series on a per CPU basis is very low. And a one core B-series is our lowest price point machine that we have. So using that effectively can pay off. The machines will start off with a baseline set of credits, and so you can boot it up. You can actually get the system up and running with confidence, and then if you have that idle use back and forth, you can be very effective there. I'll hand back to Joel. Thank you.
And also important with the B-series, in the same way that Drew just showed, when you think about those peaks and valleys, is thinking about when you structure your workloads to run as well. Right? That's another thing you can do to make best use of those credits and allow that credit time to build up. So if you're planning your workloads for those times after you've accumulated those credits, you can also guarantee that you're going to have them there to burst, have them there to burn. So it's a good thing to remember to structure those and stage those as well. So another thing that we introduced a little while ago, we talked about this kind of toward the end of the timeline. We talked about our E64i and E64is sizes. So we have these things in Azure called isolated VMs, right? And so our VMs, like we were mentioning before, they're isolated to a specific hardware. And we also guarantee that the node that that VM is operating on will not be occupied by any other VM other than yours, right? So that way, you know, it really works for people who have workloads where you absolutely have to have some kind of compliance or regulatory requirement that says, you know, your VM shall not be able to be interrupted by another VM or accessed by another VM or anything of that nature. When you go for an isolated size, then you can guarantee that you're in that scenario where it's your VM alone running on that particular server node. Nobody else's VM is going to be on there. And so we offer those in a variety of places right now. in Azure. So we were talking before about our D15 and our DS15 V2, so that's one of them that's very popular right now. We have introduced the E64i and IS sizes earlier this year as part of our EV3 family, so we rolled those out recently. The F series launched last year, so the F72 is also the largest size in the series and occupies that space, the G5, GS5, and then the M128MS also occupies that space as an isolated size. So there's several choices, and again, depending on your workload and depending on what you need, if it's more compute intensive, more memory intensive, we have isolated sizes that give you those options, right, in the cloud and available. And as we add hardware, so as we move forward in each generation of hardware that we're developing, right, and we bring new technologies to market, we also will be bringing new isolated sizes to market as well, because new hardware often affords us the opportunity, as processors grow and improve, to get more cores per se into a single blade. More cores gives us more opportunity for more VMs, and so we can actually grow those isolated sizes as well and make more offerings. And the way to think about this in a cute little graphic is, hey, if you have your server, right, and it's packed full of a bunch of different VMs of different sizes, right, then a request comes in for an E64i or an E64IS, right? So our allocator will take a look at that. It will go on the server, it'll find those empty nodes, and it's gonna go pack that node full of your single VM. And so we're guaranteeing that that entire node is now occupied by your VM, and you know that nobody else will be on there except for you. So that's what the isolated sizes are all about. We also, just a little bit about the same time, maybe a little bit after, also started offering another type of size, which we call our constrained vCPU VMs. And so these come from existing VM families that we have today. So they're offered in the M series and the EV3 series, the G series, and the upper end of that DV2 series on the 11 through 14. And the idea here is there's a lot of folks who came to us and they said, look, I need sizes that have that larger amount of memory, that have that larger throughput, local storage IOPS. I need those sizes, but I'm in a situation where I can't have that many vCPU running due to licensing restrictions and licensing reasons. And so we basically looked through all of that and said, okay, well, what we'll do is we'll offer these constrained core sizes by which you're able to purchase, let's say an E64S. So you have the E64, but now what we've done is we've given you options to have 32 vCPU out of that 64 or 16 vCPU out of that 64. So you're able to get all the benefits of the size. You get everything else going on in that size in terms of memory, throughput, local storage, all the other features, and they're all equally performant, whether it's a 32 or a 16, as the 64 parent size is. But in this case, we're holding back some of those vCPU for you so that you're able to meet licensing requirements. There's a series of places where this comes in for various workloads in SQL Server, Oracle, and other spots. And there are more, it seems to be developing, that we're hearing about. So we think that there's a real opportunity here for folks who need that, and so we've made it available. One of the things to note as a caveat on that is, we have seen customers get confused about this, which is, again, the reason we're talking about it today, because people go in there and say, well, hey, I ordered an E64, and then I get a support ticket, and they're like, why isn't my E64 running the way it's supposed to? And we go and look and say, well, no, you ordered an E64 32. You got to be careful. So make sure when you're making your selection, you actually are saying, look, I really do want a 64, or I want a constrained core size. It's just a thing that's important to pay attention to as you're going in there and looking for the VM that you need for your workload. And then coming soon, so like I mentioned before, there are a lot of new sizes on our roadmap. We've got a lot of really cool things that are going to happen in the next 6, 12, 18 months that we're planning for, and we're able to talk about some of them today. They've been talked about in greater depth in a couple other areas, but we'll cover a few here really quickly. So one is the LV2 series VM family. So this is the next version of our L series, and we'll talk about that in a second. We also have two new sizes coming, or two new families of sizes coming in our HPC series, and we're going to cover those. And then we mentioned before, we have our GPU series. So we have new offerings coming there as well, and the NVV2 and the NDV2 that expand that GPU portfolio are going to give you access to a new series of GPUs, and new workloads become available as a result of that as well. So let's touch on a couple of those, and we'll start on the LV2 series. So right now, LV2 is in preview. if you're interested in LV2 and you're interested in our preview, you can talk to me afterwards. I can help explain more about how to be a part of that. And it is our next-gen family in terms of having that local storage on node, VMs with direct access to that storage. But in this case, we're running now with a partnership with AMD. We've been co-developing this platform together for a little while now and optimizing around that processor and its capabilities. And we've created a new version of LV2 on top of the AMD EPYC, right? So we're using the EPYC processor. We're using a 32 core in this case, 2.2 gigahertz, and bursting up to, on turbo, up to 3 gigahertz of speed. But the key here, too, is that then we're able to build a VM family that offers anywhere from 8 up to 80 vCPU and has access from anywhere on the 8 from 1 near 2 terabyte drive up to 10 near 2 terabyte drives on the 80. So there's a lot of folks who have contacted us, and we've gotten phenomenal response in the preview. We have a lot of customers in there testing workloads of varying sizes, and a lot of folks are very excited because we're actually able to offer them, almost 20 terabytes of memory of NVMe to go mess with and to go run their workloads and do a lot of processing. So there's a lot of interest here, and really you're looking here at SQL, NoSQL databases, MongoDB. There's options from Cassandra, Cloudera, and others that are going to come along as well. And then, of course, we back this with our premium storage also, so you're also able to attach that because these are all S sizes, as we were talking about earlier. There won't be a non-S version of the LV2. And then in the HPC side, so we talked about this a little bit in another speech earlier this week. So we have 2 new series coming. So the first is HB. This is architected on the similar platform with AMD as the LV2, except now here we're working on, talking about your high memory, high bandwidth in the cloud. So again, we're going back to a place where you have that InfiniBand options, and we're going back to a place where you can look at like up to 240 gigs of system memory. So you're getting a lot of memory, a lot of processing power. You're getting access to a lot of cores, and it's a really exciting offering in a partnership with AMD. And on the same time, we knew we needed to differentiate as well. We were going out there and we saw that there are workloads that have differences and need things that AMD has and need things that Intel has. So we also have an offering called the HC series. So that's going to come at about the same time. And that's based on Intel. And so there's just a lot of really amazing things that we're going to be able to do with these. And there's different targeted workloads that we think these serve. So there's a lot of folks excited about them. And the cool thing is that they'll both be in preview a little bit later this year. So there'll be more details later this year about what you can do with those sizes, how you'll be able to access them. And then timing, as that comes forward, we'll also be able to talk a little bit more about when they'll become available and how we'll grow them globally. So a couple of really cool sizes coming along that we think there's a lot of potential for in the HPC space that a lot of people have been asking for, and is going to offer the opportunity to get a lot of workloads that really are much more on-prem right now up into the cloud and have that offering for the first time. We're talking to a lot of customers who just don't have that capability right now until we bring these along. So there's a bunch of customers who are incredibly excited about these because they're looking for the first time to actually be able to come to the cloud because of these offerings. So it's a great space to be in. So then, I want to hit a little bit on our Linux friends.
Certainly. So of course, we've got all of the hardware, the configuration that's there. And of course, everything within Azure, Windows is covered. But we have really been spending a lot of time making sure that we're not just the Windows shop, not just optimized for Windows. And so there has been a continuing investment in Linux. So that really hits the gamut. We've got, Red Hat's a great example. We have an integrated support agreement with Red Hat that we kicked off last year that allows for, if you have support with running Red Hat in Azure, the Azure support people and Red Hat folks are sitting together to work through your problems. We recently launched a similar solution with Ubuntu through Canonical to get detailed support. And across the set of sizes and offerings, we have very broad coverage of Linux, Debian, and in fact, in some of our appliances, you even have some free BSD running. So again, we're trying to hit the set. The goal here with the sizes, with the OS, is really meeting customers where they are. What services do you need? What applications and what software do you need to make sure that we're actually able to, be the right cloud for you for any of your workloads. And in the places where we can't support it directly on VMs, that's where that bleeding edge comes in, where we're actually running Cray supercomputers, or even outside of just the core compute side, we've got NetApp filers running as hardware devices in the data center. And so we'll continue to do that. It's all about listening to customers, finding out what the customers are needing, what's blocking them or holding them back at all, and making that available in the cloud. And you'll continue to see that from the Azure team. On the open source space, it's not just the operating systems, but it is all of the applications, all of the middleware, the DevOps, that just continues to expand. Just earlier this week, we announced a great partnership with Chef to have coordination and configuration of Linux machines. We've had Chef available in certain ways there, and we continue to go deeper across the set. And again, we're just finding that by working with partners, we're able to really serve our combined customers better by providing the widest amount of offerings available.
And also in that space too, talking about Linux there for a second as well, we also have, going back to some of this, we also have a series of teams inside Azure who are fully focused on Linux, who are fully dedicated to Linux, and who are fully ingrained with everything that is being done across these different providers and the different areas that you can be in with Linux. And it's been really cool because, for example, on LV2, we've been working to develop the LV2 platform. We've had phenomenal integration with our Linux team and then our Linux partners externally as well to make sure that as we build this platform, we're not just thinking Windows, we're not just optimizing Windows, we're not just putting the best perf on Windows, but we're working really hard to make sure that our perf appears in both places, that it shows up in both places, that we push for the best on both sides of the house and really make those opportunities available. And in fact, from the Linux space, in the LV2 preview, out of the customers we have on there, about 60% are running Linux, probably geared a little more towards Ubuntu for the most part as one of the primary areas that they're in. But about 60% of those workloads actually are on a Linux base, and we're looking forward to having them on as we go to GA on the LV2 platform, which will be a little bit later this year. So in review, we've kind of covered a bunch of different topics, but we really hope that help kind of span the gamut in terms of where is Azure today, where are we? We're in more regions than anybody else. We're closer to our customers. We're closer to where you guys want to be, where your customers are as well than anyone else is. And we've got, we kind of went through a timeline and a detailed history of where we started, where we've been, and then talked a lot about where we are today, but also talked about where we're going to go be in the future with the new VM families that we have coming along. So you get a concept of, as we continue to grow, as we continue to learn, as we continue to meet with our customers, we're continuing to look at what do we need to do to make sure that we have the VM families to serve your workloads, and we have them where you need them, when you need them, and we're going to continue to work to push on that, to innovate and get further forward on that than we are even today. And obviously, like we talked about before too, we're always working to expand that open source portfolio. We're working to make sure that we're bringing both the best in perf in Linux and the best in perf in Windows to the customers wherever we can make it available across all of our VM families, so that we're going together there in the future as well. So with that, hopefully that helped a lot of folks and covered a lot of different areas in terms of workload. There are a series of other sessions coming up. I'll just throw this up here. Later today and tomorrow and Friday as well, that are going to hit on a couple other areas in terms of where you might be looking at VMs, and again, where you might be looking at VMs for both workloads, but also other ways that you can use your VMs. And other things, like one of the sessions that might be really cool is lessons learned that we'll have from our own use of VMs that you might actually get a lot of benefit out as well. So hopefully that was really helpful, and of course, we'll stay after a little bit. If folks have any questions, we got about a minute left if there's like a hot question right now as well.
Please do fill out the surveys, give us feedback, what works, is the content right, help us continue to improve Ignite so you guys have a better and better experience there. Tell us what works, what doesn't. Is there we may have time for a question. If not, we'll say thank you for your time, and I hope you guys enjoy the rest of your Ignites.
Thanks, everyone.